Alright, before we finish the notes from yesterday, let's start organizing all of these properties that we've been talking about. Right, so the way that this little flow chart is set up, okay, every figure beneath the figure above it shares those same properties. Okay, so we're going to start with just a general quadrilateral. Write down its properties, and then everything with an arrow pointing to it beneath it shares those properties. Okay? So we have not talked about kites or trapezoids yet. We've only talked about parallelograms and special types of parallelograms. We'll get to kites and trapezoids in the next section. So for a quadrilateral, that's true. We could say it's a polygon.
Opposite sides would be parallel.
Not of just a general quadrilateral. So that'll be true when we get down to parallelogram.
Has to have 4 sides.
Has to have 4 sides. That's true.
It's got to be lateral.
It's got to be lateral. What does that mean?
But like quad is 4 laterals. I don't know.
4 sides.
I just figured out that whatever. I didn't know that.
There's one other property that we can write down for a general quadrilateral. What do we know about the angles? There's 4 of them. That kind of goes along with 4 sides. I guess we could say 4 sides, 4 angles.
I mean, how can you
There's something even more about the angles in any quadrilateral. Okay? Well, they're not all necessarily 90.
But add to 360.
They add to 360. Okay? No matter what the quadrilateral looks like, the angles add to 360 degrees. Right? So every quadrilateral on this page has these properties. It's a polygon, 4 sides and angles, and the angles add to 360. Okay, so now, straight down is a parallelogram. We talked about, I believe, 5 properties for a parallelogram. So, what are those properties? We want
Parallel sides.
opposite sides are parallel.
Yeah.
What else? Opposite angles are the same. All right, opposite angles are congruent. What else?
Hey, the angle. Oh wait, he's sitting. Alternate interior.
Yeah, so we don't really have alternate interior angles because we don't have any. Wait, would that term work? I guess that term would work. Alternate interior would work. We called them consecutive angles when we were talking about parallelograms, but yeah, actually that would work. These would be alternate interior angles because these are parallel lines cut by a transversal. So that you could call them alternate interior. So what about them?
Oh, they're congruent. Or they would add 180.
They add to 180. Yeah.
And then like the opposite sides are the same length. Congruent.
Right. So consecutive angles are supplementary, where they add to 180. Then opposite sides are congruent. One more. Jess?
Something about bisecting.
Something about bisecting.
bisect. Yeah. You do better. Yeah. Perfect.
There's nothing wrong.
What about
Can that be an
bisecting?
answer on the quiz?
The lines?
Do that.
Yeah. When yeah, like eight, like this. Here, they
What are these?
Diagonal.
The diagonals bisect each other.
Can that be a question on the quiz? Something about bisect? And the answer is the diagonal bisect.
Yes. Okay, so remember that means that if I connect the non-consecutive vertices, those are the diagonals, they would cut each other in half. Right?
It's like last room, right?
Alright, so beneath the parallelogram now, we have a rhombus, a square, and a rectangle. Okay, we've talked about all three of these now. So each of these figures has all of these properties plus a few more. Right?
Get this on the quiz.
You will not get this on the quiz.
I write it on my arm.
After I give you the quiz, sure. Alright, so let's start with rectangle, because we did that one first. So what additional properties did we have for a rectangle?
Opposite.
Angles.
All angles are right angles. That was kind of the big one.
I don't know how to. I don't know how to say it, but like not the opposite ones, like this one and this one. These are different lengths. Give me the same, right? Because that would make it a square.
So the way that we would classify a shape, we could still say that a square is a rectangle.
The rectangle is a square.
Correct.
So it can't. This is the rectangle is a square.
But a square is still a rectangle because a square satisfies all of the properties of a rectangle.
So why isn't it under?
It should be. We're going to draw in these arrows here. I couldn't find a chart that was big enough that had those arrows on there. So we're going to draw in the arrows to show that a square is also both a rhombus and a rectangle. And the diagonals are congruent. That was the other big one. Yes, because it's a parallelogram. So we know that this has all the properties of a parallelogram too. Right. So then, yesterday, we talked about a rhombus and a square. So we had three additional properties for a rhombus. Right? What were those? Diagonals are perpendicular. That was one of them. And then what? Not all four angles the same.
All four sides.
All four sides are the same. Well, that's true because it's a parallelogram. Right? That was one of the properties of a parallelogram, that opposite angles are congruent.
Oh, okay.
But we want one that's additional just for a rhombus. There's one
They're
more.
called rhombuses.
We get that one. They make right triangles. That's true because the diagonals are perpendicular. Yeah. There's another one where the diagonals did something. The diagonals aren't necessarily the same length as rhombus. They bisect opposite angles. opposites, angles. So then, finally, square just has all of the properties of a parallelogram, a rhombus, and a rectangle. Right? There is no additional property for a square. Okay? So it's just, that's true because it's a rectangle. Or
Oh, I didn't know that.
So we can just say all properties, they do. Rhombus and rectangle. Right, so this is going to be a useful sheet as we keep progressing in this quadrilaterals chapter to keep all these properties straight. Right? Questions? All right, so go ahead and get out the note sheet from yesterday then, and we'll finish up the, yeah. What's that? Geometry? Trigonometry.
Well, trigonometry.
Gotcha.
So who's telling when you're doing that to do this?
So my bus will be on my property. Bus driver says that's included in the driver.
Alright, so on the back, we are going to take a look at given coordinates, proving that something is a rhombus, a rectangle, or a square. So we've already looked at proving that something is a rectangle. Right, we looked at a couple of different ways by either showing that the diagonals are congruent using the distance formula, or showing that opposite sides are parallel and consecutive sides are perpendicular. Okay, so on these problems, we're going to assume that we're given a parallelogram. Okay, we know it's a parallelogram, so we don't have to go through the process of finding or proving that opposite sides are parallel or opposite sides are congruent. We already know that much. Okay, so to take it one step further then and figure out whether the parallelogram is a rhombus, a rectangle, or a square, we want to deal with the diagonals. Okay, because we have a few special properties for the diagonals for both a rhombus and a rectangle. Right, we know that in a rectangle, the diagonals are congruent. And we know in a rhombus, the diagonals are perpendicular. So, let's find the length and the slopes of the diagonals. That's going to give us a lot of information. Okay, so, if we use the distance formula to find the length of AC, right? See A and C, so x2 minus x1, we can do -3 minus 5 squared plus -3 minus -3 squared. So, what does that come out to be? 8. Okay, again, you can just put that in the calculator. And since we have a picture, these diagonals actually end up just being perfectly straight lines, so we could actually just count that length. Okay, but I mean, a lot of the time it's going to be quicker to not sketch out the picture, right? Just calculate these lengths. So we can just see that that length is 8 from the picture. For BD, we want to do the same thing. Find the length. So x2 minus x1 plus y2 minus y1. And again, that's going to come out to 8. So the diagonals are the same length. That automatically tells us it's a rectangle, right? It still could be a square, right? We could still show that the diagonals are also perpendicular, right? But for right now, this at least proves that it's a rectangle. Right? So we want to see if we can go one step further then and see if the diagonals are perpendicular. So I want to find the slopes. So the slope of AC, right, remember slope is y2 minus y1 over x2 minus x1. So y2 minus y1, negative 3 minus negative 3 over negative 3 minus 5. So we get 0 over negative 8, or just 0. Slope of BD, y2 minus y1, 1 minus negative 7 over 1 minus 1. So we get 8 over 0. Say what? All right, like these two. So we have a slope of 0. Right. And what do we call the slope if we get a 0 in the denominator? Undefined.
I know
And,
it's really a circle. That kind of thing. I can't
no, because a circle with a line through it means no solution or the empty set. So that's a little different than undefined. So what's the relationship between a slope of 0 and an undefined slope? Are those perpendicular or not? Yeah, right, because a slope of 0 means a perfectly horizontal line, and an undefined slope means a perfectly vertical line.
remember. Fine. Maybe just make it like hold like vertical. So that why didn't help me to find it is defined.
Well, it's not because we get a 0 in the denominator. Anything with a 0 in the denominator is undefined. You can't divide by 0.
I mean, you can't divide by it, but what can you call it? Like vertical or something that's what it makes it.
If we're talking about slope, yeah, it makes it a vertical
I
slope, but it's just kind of generalizing anything where we get a 0 in the denominator is undefined. So we just call the slope undefined then. So what we found is our diagonals are both congruent and perpendicular. So this makes it a rectangle. This makes it a rhombus. So since this figure shares both of those properties, okay, it's both a rectangle and a rhombus, that means it's a square. Okay, so if we're already told that something is a parallelogram, all we need to do is find the length of the diagonals to see whether or not it's a rectangle, and the slope of the diagonals to see whether or not it's a rhombus.
So why do you know it sounds square?
If the diagonals are parallel, then it's not even a shape. For the distance formula, it doesn't matter. I mean, I could make this point x2, y2, and this point x1, y1. For the slope, it comes out to be the same thing. It doesn't matter which point you define as x1, y1, and which one's x2, y2. it'll always come out to be the same thing.
How do you know it's not rectangle?
It is a rectangle.
I mean, okay, so how do you know it's not square?
It is
Okay, but like, what do we call it?
a square.
Okay, so why don't we say rectangle? Because it's covered in
Because it's both a rectangle and a rhombus.
Okay, so if we can prove that it's a rhombus and a rectangle makes it square, but if we can prove one, it's one the other.
Right. Yeah, so if we were able to show that the diagonals were congruent, but the diagonals were not perpendicular, then it's just a rectangle. Or if we were able to show the diagonals weren't congruent, but they're perpendicular, it's just a rhombus.
Okay.
But if both of these things are true, then it's a square.
That's what the same with the other things too. Like we were trying to prove, like if when we trapezoids are the same thing.
So since those aren't parallelograms, those are going to be kind of a whole different beast. So
They're not hard to do.
no, it's actually easier, I think.
Okay.
But it's just different. So any other questions on this idea here? All right, so there's a couple of practice ones at the bottom here. So why don't we go ahead and try some of these? You don't have to. All right, did we get these answers?
Yeah.
Number one's a square because the diagonals are both congruent and perpendicular. And number two is just a rhombus because the diagonals are not congruent, but they are still perpendicular. Right now, on all of these examples, we end up with slopes of 0 and undefined, but just understand that the slopes just have to be perpendicular, right? We can have a slope of 2/3 and -3/2, okay? As long as they're perpendicular, it's a rhombus. Yes. Any questions on this stuff?